minutes and we will start. I've been told that there's at least one person who doesn't speak Swedish that's going to attend this webinar, so I will be presenting it in English. And we're going to talk about the best practices for ACI-network. We're not going to dive into every setting that can be done. I'm going to talk about mostly the things that I've seen and helped customers fix or are about to help customers fix. So we're going to start diving in. Oh, damn, I need to start the presentation mode. There you go. There you go. And here's the agenda. I'm going to start to talk about a minute about me, who I am. Then we're going to talk a little bit about Cisco ACI networks. What is Cisco ACI? Then we're going to talk about the most common best practices for Cisco ACI networks. I'm also going to talk about upgrades and recommended versions and stuff like that. And then we're going to come into the meat of this presentation, the most common faults in your DC networks. I have 5 that I've seen and helped customers or are about to help customers fix. And we will have a Q&A at the end of this session. And if you have any questions during my presentation, write them in the Q&A window and I will answer them during my Q&A session. I won't take them directly. And you will also get an email from me after this session where you can write me emails and I will answer the questions in the emails. Okay, so about me. Joakim Vikander is my name and I work at Conscia and I've been here since 2017. Been a CCIE in data center since 2015. There you go. Since 2015. And I've been working at Conscia since 2017. I'm also part of a community that Cisco's hosting called Cisco Insider. I was awarded the Cisco Customer Advocate of the Year at Cisco Live in Amsterdam this year. And I also won a ticket to Cisco Live in Vegas earlier this year as well. So I've been to 2 Cisco Live this year. I work with Cisco ACI and automation of Cisco ACI about 95 to 99% of my time during the weeks. I work a little bit with Cisco UCS and Cisco HyperFlex and stuff like that as well, but mainly it's Cisco ACI. What is Cisco ACI? Or Cisco ACI networks. What is Cisco ACI? Cisco ACI stands for Cisco Application-Centric Infrastructure. It's the software-defined data center network that Cisco came out with a couple of years ago. And all ACI fabric functionality is exposed through an northbound REST API. Cisco ACI uses leaf and spine technology with Cisco Nexus 9K switches, 9000 switches. You have fixed switches that can be only spines or only leaves. We have also switches that can be both leaves and spines, and you choose the role when you adopt the switch into the Cisco ACI switch. And then we also have modular switches like the 9500, where you can have multiple line cards in the switch, but you still choose the mode for the whole switch. You can't have one line card as a leaf switch and another line card as a spine switch. You choose the role for the whole switch. And Cisco ACI uses a policy model to define how applications and attached systems communicate. Cisco ACI utilizes several new constructs. And for you who are already working with it, you know all these things. Endpoint groups, it's a collection of endpoints. Endpoints is everything that's connected to an ACI fabric. Servers, load balancers, firewalls, whatever you have. Even virtual machines are called endpoints. You have application profiles where you can have multiple endpoint groups in one application profile. It's just a logical construct to collect your endpoint groups in groups of applications and stuff like that. We have contracts because Cisco ACI is a whitelist network from the start by default. nothing is allowed between endpoint groups by default. Then we need to have contracts to allow communication between endpoint groups. And in the contracts, we have filters and we have loads of other policies how we build things in Cisco ACI. And we can build Cisco ACI in multiple ways. We can have our standard one data center Cisco ACI fabric, which is called one pod, single pod. We can build in separate locations with stretched fabric. It's not recommended to use stretched fabric anymore. It's moved over to multi-pod, and then we can have multi-site. And I'm going to show you with pictures what these different things are. On the top of the picture, you see stretched fabric. The reason why we don't recommend building Cisco ACI in multiple locations with stretched fabric is the border leaves, the leaves between the pods that are connected to both pods. These leaves, you can't have any servers. It's not recommended to have any servers connected to these leaves because the traffic between the pods can exhaust all the resources within those leaves, so they can't handle traffic to and from servers as well. That's why Cisco came out with multipod. You get the exact same functionality as the stretched fabric, but you add an IP network between the pods. And there are some limitations on which hardware you can use and how you set up this IPN network. And we're utilizing multi-protocol BGP EVPN over the IP network between the pods. There is a special case when we're running only two pods. We can have a direct connect between the spines. We can have it in fully meshed, as I shown here, and we can have it in direct connect with not fully meshed, just connected between the two spines. I'm actually running this at one customer and it's working pretty good. You need to have pretty new software. I think it's 527 or something like that to be able to do this, but it's possible. But you can't add the third pod if you want to do this, which you can with an IPN network. The cool thing is it's really easy to migrate from this direct connect or back-to-back connection to an IPN connection without traffic interruption. And so if you want to add a third pod, you can do that very, very easily. And if we're talking about multi-site is that when we have two separate ACI fabrics with separate APIC clusters, which is the controllers of the ACI fabric, you can have them connected by layer 2 or layer 3 and stretch traffic between the ACI fabrics, as you see in the topmost part of the picture. Or we can use what's called in the picture called multi-site. There is a controller of controllers. It was called multi-site orchestrator earlier. Nowadays it's called Nexus Dashboard Orchestrator, but it's the same thing. What it means is that we do most of the configuration, not all configuration, in NDO, Nexus Dashboard Orchestrator, and we do some configuration in the local APIC cluster and controller clusters per site. And with NDO or multi-site orchestrator, you can stretch networks between the sites. I should mention this, that when you're building multi-pods, you can't have the pods too far away from each other. You have limitations of 150 milliseconds round trip time. But when you're building a multi-site, we have a 1 second round trip time between the sites, even if we're going to stretch the fabric, the networks between the sites. So now we're going to talk about the best practices. I'm going to start talking about the APIC connectivity. APICs are the controllers, as I said earlier, so it's for application-centric policy infrastructure controller. And we have a couple of ports that we must have connected. We have 5 ports that we need to have connected, or actually 3 is the mandatory we need. The 2 out of band management is a best practice to actually have connected. The first one, we have SIMC copper. SIMC is basically like the ILO or iDRAC on HP and Dell servers. And why we need to have this connected is because we need to upgrade the SIMC software when we do an ACI upgrade, because there's a correlation between the softwares, but I'm going to talk about that more when I talk about the upgrades. Out-of-band management, which have 2 copper ports, and this is the recommended way of using or controlling the ACI fabric via a separate network with not connected to the ACI fabric. If you have them, you can run what's called in-band management, but you can run into a moment 22 if you have it in-band management, because if you're having an issue in your ACI fabric where you can't control your ACI fabric, you can't reach your controllers, then you can't fix the problem in your ACI fabric. But if you have the out-of-band management connected, you can always reach the controllers, and you can manage the controllers, which in its way controls the fabric, the switches in the ACI fabric. And then we have the leaf interfaces, which is 2 SFP interfaces, might be 4 ports, depending on which version of APIC you're running. The newer versions are always delivered with 4 ports, and we recommend to connect them to 1 port to each leaf. And if you can, distribute the APICs to different leaf switches, so you don't have all the APICs connected to the same leaf switches, leaf pairs in each pod, if possible. And we're talking about the connections. Here we see the SIMC port, which is 1 copper. We have the out-of-band management copper ports, and we have the SFP ports. And keep in mind, when you're connecting the SFP ports, you can't connect port 1 and 2 or port 3 and 4, sorry, to the same two different leaf switches, because the server in the background is bonding the two of the ports. So port 1 and 2 are a bond presented to the APIC controller, and port 2 and 3 are another bond presented to the APIC software. So when you're connecting the SFP ports, connect 1 and 3, 1 and 4, 2 and 3, or 2 and 4, not 1 and 2, 2 and 3, 3 and 4. I've seen this been done, and that's been a nightmare to actually figure out what the issue was. That was the first APIC with that kind of SFP cards in it, and once we figured it out, it started working pretty good. Well, actually, really good once we figured it out. Switch connectivity. We want to have a fully mesh between the leaves and spines in the same pod and site if you're running multi-X, multi-site, multi-pod. There are one exception, and I'm going to show you a small picture about that, which you can have a multi-tiered leaf structure, meaning you can have sub-leaf or tier 2 leaves connected to the tier 1 leaves, and you will have your servers connected to the tier 2 leaves. You can have them connected to tier 1 leaves as well. This is to compensate for the FEXs, the fabric extender switches that are going out of production. You can have cheaper tier 2 leaf switches with just copper ports in them and stuff like that if you want. And that's about the topology. Now we're going to talk about the configuration. We have 3 settings we are talking about here, three settings. Limit local IP learning. It's a setting you can do per BD, per bridge domain, which is the layer 3 domain in the ACI fabric. And it prevents unnecessary or unintended local endpoint learnings based on the subnet configured in the bridge domain or endpoint group. Meaning, if you get a packet with a source IP address that is outside of the subnet that is configured for that network in ACI, ACI won't learn its IP address. Then we have an enhanced version of limit local IP learning, which is called enforce subnet check. This is done globally. You do it once and it's enabled for the whole ACI fabric. And it prevents the ACI fabric from not learning IP addresses of locally connected endpoints. It also prevents the learning of what we call external endpoints. So this is the preferred way of doing this. But if you already have a network up and running, it can be disruptive to actually enable this enforce subnet check. So I've actually, in an ACI fabric, recently figured out that we need to have this limit local IP learning based on it's up and running, and we're seeing some issues. And I'm going to talk about one of those issues that we're seeing. And the third and final endpoint learning setting is endpoint IP aging. By default, each endpoint has only one timer. The MAC address is based on the MAC address. And you can have multiple IP addresses per the same MAC address. But if the MAC address is timed out and the server isn't using that MAC address anymore, it will still be learned in ACI because the endpoint learning is based on MAC address. Then we can enable a global settings, which is endpoint IP aging, and we will have a separate timer for IP addresses as well. This is by default disabled in ACI, and we recommend you to enable it. We have loop mitigation settings. I've seen a couple of issues with loops, specifically spanning trees. Miscabling protocol, or MCP, it detects loops from external sources and disables the interfaces when it sees some bad packets, or actually when it sees, because MCP works in a way that it sends out a special packet with itself as the source, and if that packet comes back to another leaf switch or another port in the same leaf switch, ACI knows that this packet has been looped around, and ACI will disable the port the packet's coming in on. And this is really good if you're running spanning tree. You have switches connected that are running spanning tree. And MCP is enabled globally, and you set a password globally, and then you select which port you're going to run MCP on. So it's enabled globally, but it's not enabled on the ports by default, on all ports by default. EP endpoint loop protection and rogue endpoint control. EP loop detection detects a loop by detecting an endpoint being learned on the same set of two interfaces back and forth, i.e. called MAC flapping. Rogue endpoint control identifies an endpoint MAC IP address as rogue when the same endpoint is learned on different interfaces. And the endpoint loop detection can be set to either disable. It can actually disable the port, which is one of the ports that the MAC address is flapping from to and from on, or we can set it up so it disables learning on the bridge domain, endpoint learning. So we put the bridge domain in a freeze state. So new endpoints, no new endpoints are learned anymore. It's a limited time. And we can also have other settings enabled, but the best thing is that I would always recommend to have port disabled, because then we can cut it off and don't affect other endpoints. Rogue endpoint control is it will freeze the endpoint on the port that it sees the last time before it actually takes an action. Meaning, if the endpoint moves to the other port, ACI won't learn it on the new port. It says it's still active on the first port. And this is the best practice is to actually enable this endpoint learning, rogue endpoint control, and which is it acts per endpoint instead of per port or per bridge domain, which endpoint loop detection, endpoint loop detection does. Bridge domain settings, which is the layer 3 domain. Unicast routing. It enables bridge domains to route traffic and learn endpoint IP addresses. You can have unicast routing enabled without have a subnet configured in the bridge domain, which means that ACI will learn IP addresses of the endpoints. But it's not recommended to have this enabled if you don't have an IP address enabled on the bridge domain. Layer 2 unknown unicast. This is used to decide if the bridge domain should flood packets that are destined for an unknown MAC address or send it to a spine for the COOP database lookup. COOP is a special protocol that only ACI utilizes that I know of. COOP stands for Cooperation of Oracles Protocol, which means that when an ACI leaf is learning a new endpoint connected to the ACI leaf, it will collect the MAC address and the IP address if unicast routing is enabled, and it will inform one of the spines within the pod or site. I've learned a new endpoint and it's connected to this port on my switch. And then all the switches will communicate with each other and learn where all the endpoints are learned. And if you don't have layer 2 unknown unicast enabled, if you are having a layer 2 network or something like that, then ACI will actually talk to the spine switches and try to learn where a connected endpoint is. So if we have silent hosts or we have hosts that, silent hosts that haven't been talking in a while, meaning the endpoint has timed out from the endpoint database, or it has never talked on the ACI network, we will never find out where it's connected. So when we're having a layer 2 network where we don't have layer 3 routing enabled, we recommend to have layer 2 unicast enabled, because then ACI will flood the traffic and we will find where the endpoint is connected with the unknown MAC address. And it's recommended to have unicast routing enabled when unicast routing is disabled and when we're extending layer 2 traffic outside of Cisco ACI to non-Cisco ACI switches, such as during migration or stuff like that. And ARP flooding, and this is the same as layer 2 unknown unicast, but for ARP request instead. ARP request is handled by the same mechanism by default, the COOP protocol, when there's an ARP request coming into a Cisco leaf switch. And if you're enabling ARP flooding, it will be flooded throughout the ACI fabric or pod or site. The best practice option is to have this enabled when we have clustered servers, firewalls, or load balancers, so that we can have the gratuitous ARP flooded in the network. Not always have this enabled, but sometimes we need to have this enabled. So now we're going to talk about upgrades and recommended version, but I'm going to do this in the backwards way. I'm going to start with recommended versions. Version numbering has changed. Earlier, before 6.x, it was always the .2 version that was the recommended version, which is called the maintenance release. The .0 and .1 are and was always a feature release, where Cisco came out with new features and new functionality and stuff like that. From 6.0, there's a new letter at the end of the release number, which indicates if it's a feature release, an F, or a maintenance release, which is an M. For example, we have 6.03EF, which is a feature release, which is by accident the latest release that is available for Cisco ACI. 6.4 something M, which I think is going to be released around the new year, something like that, will become the new recommended versions once we have a recommended version. And going forward, it will be the same. All feature releases will have an F, and all maintenance releases, which will become the stable release with no new features incorporated into them. And today, the recommended version is 5.28 Eric. This is the latest and recommended versions. And as long as you don't want to you don't need to have a feature that is only available in the newest feature release, it's not recommended to actually go to a feature release. It's recommended to stay on a maintenance release. Cisco ACI upgrade. When we do the upgrade, we have 3 different softwares to be considered. We have the APIC SIMC software, we have the APIC software, and we have the Nexus 9K software. The cool thing is, when we're talking about the Nexus 9K software, it's only one software. We don't have to take care of what kind of switch it is. There's only one software. It's quite big, but it's not that big as if we're talking about sizes compared between APIC software and Nexus 9K software. But it's around 2 gigabytes, I think it's today. The APIC software is around 8 gigabytes if you're talking about uploading it. And the APIC software is around 700 to 800 megabytes when you do the upgrade. And we need to take care when we do this upgrade, because APIC software and the SIMC software is correlated. I have one of the issues when I'm going to talk about. We see what happens when you don't do the upgrade in the wrong order. First upgrade the APIC software and then upgrade the SIMC. I will talk about that a little bit later. So when we're talking about doing an upgrade, we always need to check the release notes. And pretty far down in the release notes, we have a special chapter called miscellaneous compatibility information. And here we find which SIMC versions are compatible with this version of ACI or APIC software. And we see that Cisco switch software is 15.2.8. I'm looking at the 5.2.8 Eric release of ACI. And we can see that there are quite a lot of SIMC versions that are compatible. But we always recommend to, at the end, go to the latest recommended version for the version of APIC you're running. If you're running L2, M2 or M3, L3, depending on which version you're running. And M4, APIC M4 or L4 is released, and you need to run 6. something software to do that. So we need to look in that versions. So when we're doing the upgrade, we have a procedure. If necessary, upgrade the SIMC to a version supported by both old and new APIC software, meaning if we upgrade, we don't run into issues. If we already are on a SIMC version that is supported by the new version, then we can skip this step. Then we will do the upgrade of the APICs, which is when you do it from the GUI, it's a one-click, and then you just wait. You do the upgrade of the switches as the next step once the APICs are updated and done. And when we do the upgrade of the switches, we will divide the switches into upgrade groups. Basically, when we're running multi-pod, I divide them into at least 4 different groups. So I will upgrade half of the switches in one pod, and then next upgrade, I will do half of the switches in the other pod, and go on and so forth. You can upgrade half of the switches and then you can wait a week or two, maybe 3, maybe 4 if you want. It's not recommended to run different versions of the switches for a very long time, because you can run into issues with, if you're upgrading from, for example, 4.2 to 5.2, which are 5.2 have a lot of new features in them, and it can be an issue when you're running different versions. And the last step is upgrade the SIM-C to a version recommended by the new release. Each of these steps takes some time. For the upgrade of the Apex, it takes about 40 to 45 minutes to an hour per APIC. So if you're having a 3-cluster APIC, you can at least calculate about 2 to maybe 3.5 hours. And when you do the upgrade of the APIC, you just, as I said, one click, and then it will start to upgrade the APICs in number order. It will start with APIC number 1, and it will wait until APIC number 1 is back into the cluster and fully fit into the cluster. Then it will start with APIC number 2 and wait and wait and wait to do the same thing for 3 and 4 and how many ever APICs you have. Upgrade of switches, it takes about maybe 20 to 25 minutes. Each reboot of a switch takes about 10 minutes, and it's going to sync out the software and stuff like that. And upgrade of the SIM-C version, that depends on which version of the SIM-C you're on and you're upgrading to, because they've done some really cool upgrades to the newer version of the SIM-C, meaning that they've cut the upgrade time down to, I think it's half an hour maximum. Earlier it was at least an hour, depending on how you're mounting the SIM-C ISO when you're doing it. We can do that remotely. We can mount the SIM-C ISO via HTTP, via NFS, no, not NFS, via the KVM, which is available and stuff like that. So when we're doing upgrades, we always look at the matrix, the upgrade, the Cisco ACI upgrade matrix, to see if we which version we choose which version we are from and which version we are going to, and then we can see if we can do it directly or we need to do a middle version in between, depending on which version you're on. For example, if you're going from 3.2 to 5.2, there's no direct way of doing that. You need to land on something 4.x before you can upgrade to 5.2. And there's an upgrade script, a validation script that it's recommended to actually run this. If you're running Nexus Dashboard in your ACI Fabric, this is actually built into Nexus Dashboard. And if you're one of the unlucky who's actually started using Nexus Cloud, it's also built into that. But this is a GitHub link where you can download the latest version of this script. It's a Python script that you upload to the APIC and run it on one of the APICs. And it will get you an all clear, or it will get you some errors that you need to fix before you start upgrading the APICs, because some errors can actually affect the upgrade. So now we will start with the 5 most common faults in your ACI network. Issue 1, Cisco APICs in a never-ending boot loop. We have 2 possible issues. First one, that's one that I actually did. Ignored SIM-C upgrade version during an upgrade of the Cisco ACI or APICs. The APICs need a deep connection with the hardware within the APIC server. This is given by the SIM-C. If server doesn't see the CPU, memory, PSU, fans, or whatever, it will be stuck in a never-ending boot loop. The case I'm talking about, there was a combined issue, because we have both a bug in the SIM-C, where if the SIM-C had been up for a long time, it stopped presenting the hardware to the APIC when we did a reboot. So there was a workaround to actually have the APIC disconnected from power for 1 to 2 minutes, and then we could reconnect the power and reboot the switch, and it started working again, and do an upgrade to a recommended version of the SIM-C as well. And I've seen a colleague of mine down in Holland or Netherlands actually saw the second one. The APIC didn't see the power supplies. they'd upgraded to a recommended version of the SIM-C, but the APIC didn't see the power supplies, which resulted in the APICs getting into a never-ending boot loop. So the workaround for them was to actually upgrade to an unrecommended version, a newer version, which had a fix in it so that the SIM-C could present the power supply to the APIC, and that resulted in a attack case, and Cisco, it took about an hour for Cisco to update their documentation to actually upgrade to have that newer version of SIM-C recommended. Connecting spanning tree switches to ACI. When we are connecting switches that are part of a spanning tree topology to Cisco ACI, there are a couple of things that we need to keep in mind when we do this. Cisco ACI doesn't participate in spanning tree topologies. It will forward the spanning tree BPDUs, but not block any ports based on SDP information, spanning tree information. When Cisco ACI receives a spanning tree TCN or topology change notification, BPDU, it will clear the endpoint database for that EPG VLAN that the VLAN is received on. Keep in mind, this is if you're running rapid PVSD plus or something like that. If you're running MST, it will actually affect all the EPGs that are part of the same MST spanning tree in the background, in the spanning tree network. So we can fix this by doing two things. We can enable two spanning tree features on the ports where the spanning tree switches are connected. We can have spanning tree guard, or we can have BPDU filtering. BPDU guard prevents loop by moving a port into this error disabled state if it receives a spanning tree BPDU on that port. And we will break the loop in that way. It's not a good way of doing this because we can actually cut off ourselves from the spanning tree network if we're having issues with BPDU guard and stuff like that. The better way of doing this is doing BPDU filtering. It prevents sending and receiving of any spanning tree BPDUs on any ports or on the ports that we have it enabled. Any BPDU that is received is dropped when filtering is enabled by Cisco ACI. And it's enabled if you're running via virtual machines, virtual Ethernet, or if you're running what's it called, AVE, application centric virtual edge switch, or called Nexus 1000V development for Cisco ACI. And this is a way of doing it, but there are some drawbacks when we're doing this. So if we're talking about doing this, we have our basic ACI network where the spanning tree network connected to the ACI fabric. And if we're enabling BPDU guard on the spanning tree port or the ports connecting to the spanning tree network in ACI, we can actually cut off the spanning tree network from the ACI fabric, because if we're receiving BPDUs on both ports, we will cut off both ports. And as long as they're error disabled, we need to go in and actually re-enable them by hand. There's no timer or an auto enable by default in Cisco ACI. So the better way of doing this is having BPDU filtering. The best way of doing this is actually, as I've shown you with the yellow dots, have it both ends, both in Cisco ACI and in the spanning tree network. If you don't want to enable it in Cisco ACI, it's enough if you just have it on the spanning tree network switch. As I said, the best solution is have BPDU filtering enabled. We can cut off ourselves and it won't block any port, it will just drop the BPDUs if it's coming in. And when we're connecting the spanning tree networks to a multi-pod set up, we have BPDU filtering on the spanning tree network or in the ACI fabric or both. We will effectively cut off the spanning tree domains. So if we earlier had one spanning tree domain, now we will have two spanning tree domains. They don't know about each other because there will go no spanning tree BPDUs between the spanning tree domains. They can have the same name and the same password and stuff like that, but they will behave as two spanning tree domains. So that's one thing to keep in mind when we're actually doing this. Issue number 3, traffic loss in application-centric ACI implementation. Application-centric is the way of building networks when you have multiple EPGs associated to a single bridge domain. You can have separate subnets in the EPGs if you want. It's not recommended, but you can. But we have one small virtual Linux machine with 2 or 3 network cards that was acting as a VPN, remote access, gateway, or something like that. Out of the blue, meaning there was no configuration change on the Linux machine whatsoever, it started bridging the traffic between the 2 or 3 network cards it had. Meaning that Cisco ACI, started learning multiple IP addresses, and it was actually quite a lot of them on one and the same MAC address, meaning Cisco ACI sent all traffic to this Linux machine, and this Linux machine couldn't handle all the traffic. And as I'm saying, during the troubleshooting, we figured out it was the same MAC address, and then when we cut off this Linux machine from the ACI fabric, we started seeing traffic going back to normal behavior, and we got back endpoints and stuff like that. And we can actually mitigate this pretty good by enabling limit local IP learning or enforce subnet check. That way, Cisco ACI is forced to only learn IP addresses which are connected to the local network. Very good. And if you're building Cisco ACI with an application-centric setup, we have another setting that I haven't talked about yet, which is called multi-destination flooding. By default, the flooding in the ACI network is done on the bridge domain, meaning if you have multiple EPGs or VLANs connected to the same bridge domain, we can have flooding over multiple IP networks if we have separate IP networks in the EPGs or VLANs, and that's not something we want to do. We want to have flooding within a VLAN or EPG, and then we can enable this change this multi-destination flooding to be on the encapsulation instead, meaning it will stay within the EPG. By default, Cisco will flood, as I said, in the layer 3 domain in the bridge domain over multiple EPGs. Issue number 4, intermittent traffic loss to virtual Linux servers. The customer have virtual Linux servers with multiple network cards in all Linux servers. We're talking about 5 to maybe 10 network cards, and all network cards are in different networks. EPGs, VLANs, or VXLANs, or whatever you want to call it. The Linux distribution the customer uses allows traffic coming in on one network card and the response going out on another network card with the source IP address in the wrong network card, on the wrong network card, but the correct MAC address. Meaning the traffic will come in on another EPG with the correct MAC address with the wrong IP address. And Cisco ACI by default will learn any IP address as long as we have unicast routing enabled. So we're seeing at that customer, we were seeing actually that they were losing traffic. They lost something like 20 to 25% of packages while doing a simple ping. And when we started tracing this traffic, we saw it came in on one interface and went out on another one. And Cisco ACI didn't understand where this traffic is going because it learned the wrong IP address. So, how to fix this? The hard way of doing it is have separate routing tables or VRFs or whatever you call it per network card in virtual Linux machines. We tried to get the Linux administrators to do this and they couldn't figure out how to do it. Then we showed them, but they thought it was too much work, so they didn't want to do that. So what we've started doing is limit local IP learning to bridge domain EPG subnets, meaning Cisco ACI will not learn the IP address and the traffic will not be affected. The better way of doing this is doing enforced subnet check, which I have done in a new ACI fabric in a new location for the same customer. So when we're moving into that place, we will not have this issue when they're running Linux machines with multiple network cards. And the last one, issue number 5, virtual load balancer stopped Cisco ACI from forwarding traffic. We had Cisco ACI with multiple networks and one virtual load balancer. It was a Citrix load balancer, if I don't remember wrong, with multiple network cards. It's based on Linux. No one had been logged in for over a month in the load balancer and not done any changes to config of the load balancer during the same time or even more time frame. The load balancer started out of the blue, bridging between the networks. Cisco ACI was seeing the same MAC addresses on all IP addresses that was bridged by the load balancer, meaning no endpoint connected to ACI was reachable. ACI couldn't forward any traffic because it couldn't figure out where to send it because it was happening so fast, the changes of MAC addresses and IP addresses association. So Cisco ACI just said, I'm not going to do anything with this. During the troubleshooting, we figured out, as I said, we see the same MAC address on all IP addresses. And when we figured that one out, we disconnected the virtual load balancer and traffic started to return slowly because the timer is quite long. I think it's about 6 minutes for the endpoint table to actually time out. And the same thing here. We could have set up limit local IP learning, or we could have enforced subnet check enabled. And as you can see, we have multiple issues when we don't know how to configure Cisco ACI correctly. And I'm saying I'm very fortunate to work with multiple customers, and I'm learning new stuff every day about how to best practice set up Cisco ACI based on the customer's requirements and stuff like that. So, Q&A. I see we have one Q&A. We have one question in the Q&A. What is the best practice when connecting Hyper-V host to ACI leaves? What kind of setting need to be set on the virtual switch in Hyper-V? You can do it in 2 different ways. We can do what's called an integrated virtual machine integration, VMM integration in ACI, meaning Cisco ACI will actually create the virtual switch in Hyper-V if you want. Or you can do it without the integration, and then I'm not exactly sure what settings you actually need, but there's no special settings. It depends on what you want to achieve. If you want to have virtual machine isolation, meaning you want to have one virtual machine can't talk to another virtual machine in the same network, then we need to start talking about private virtual private net LAN, VLANs and stuff like that. I'm sorry, private VLANs and stuff like that. But keep in mind that Hyper-V is not actively developed anymore by Microsoft. They're nowadays always pointing to Azure Stack. And you can't do an integration with Azure Stack. You can have it connected without the integration if you want to. There are some new things developing and being announced in the last 2 weeks that I'm not going to talk about today, but we can do a deep dive in that if you're more interested. Any more questions? Otherwise, we will proceed to what's next. Okay, we will proceed. Next Tuesday, my colleague, next Tuesday, September 26th, between 12 and 1 o'clock, my colleague Sebastian Andersson will host a hybrid webinar event about automation of Cisco ACI. He's part of the company that Conscia actually bought just before the summer, called Miradot, and Miradot has developed a really well functioning and cool framework on how you should do automation of Cisco ACI, which is it's everything involved in the automation. This event will take place at our Stockholm office in the DN-skapan, as it's called in Stockholm, and on the web. If you're attending on live or in our office, you will be served with lunch if you're there, and I will paste the URL for the registration in the chat window if you want to register for that event and participate. We have a question in the chat as well from Emil Olsson. Do you have any courses or books that you recommend to anyone starting with ACI? There are a couple of online courses that I actually recommend, but most of them are pretty old. But you will get an email from me, not sent by me, but it will look like it's coming from me in the coming days after this webinar, where you can ask me questions. You will get that email, you can answer that question, and I can answer your question. So please write this question in an email for me, and I can look into if there are any newer updated courses, online courses that you can take, and what new books there are out there, and I will get back to you about that, Emil. I posted a URL for the registration of the coming event in the chat if you want to register. And by that, I'm actually done if you don't have any more questions. Okay, cool, man. Then I will thank you for this, for attending this webinar. And as I said, you will get an email in some of the coming days, and you can start asking me questions via email, and I will have more time to actually try and respond to your question with the best practice, how to do things and stuff like that. So I will thank you for this, and I will stop sharing.